Hi, welcome back to Quantitative channel. I'm Jagu Wong. Today we are going to look at module Perkembangan Pembelajaran SPM 2021 by Terengganu State. Okay, let's see the structure questions. So section A, table shows the percentage of composition of metals in alloy. So you are given a few types of alloys here. Okay, first one is the duralumin. You can see the composition. So 93% is aluminium, then 3% copper, 3% magnesium, and 1% of manganese. So duralumin normally used to make the electric cable and then racing bike, and then actually it can be used to make the body of the aeroplane. Okay, next is bronze. Okay, bronze, the composition will be copper 90%, and then stannum actually is a tin as 10%. Okay, next one will be brass. So 70% of copper, then 30% of X. Okay, later on definitely the question will ask you what is X. Okay, so based on the table 1, okay, so state the element X. So we know that the brass is a combination of copper with zinc. So we have to state the elements X. So you can use the formula, you can use the name. Okay, so both are accepted. So zinc, or you can also use the formula zinc. So 1 mark. Okay, so number 2, state another use of duralumin. Okay, just now I mentioned already, it is used to for building, okay, or making the body of aircraft or aeroplane. Actually, another one is it can use to make the body of bullet train as well. Okay, it is very light but it's very strong. Okay, now I give another example of alloy. So you can use any example of alloy that you know. Okay, for example, let's say steel. Okay, what else? Like just now here, okay, you can mention actually many more. Okay, like pewter or any accepted alloy. Okay, in the syllabus. Okay, now explain why the bronze is stronger than the pure metal. Okay, yeah, so this question is a very important question, so everybody must know. Okay, so first you can mention the pure metal, or you can use mention the bronze or the alloy. Okay, so first we can mention bronze. It consists of atoms. There are two types: atoms of copper and tin. Okay, they have different sizes, so of different sizes. Okay, so you must know that they have two different types of atoms, and then these atoms are different sizes. Okay, so this is the first point. Number 2, okay, because of the different sizes here, okay, so these atoms disrupt the orderly arrangement. Okay, of atoms like in pure metal. Okay, so in pure metal, because of the same sizes of the atoms, right, because they consist of only one type of atoms, so the arrangement is very neat, and then it is orderly arrangement. But if the different sizes, then this orderly arrangement is disrupted. Okay, so what is the consequences? So when force is apply. Okay, what happened? The layer of atoms are not able to slide over one another easily. Okay, question number 2. Diagram 2 shows the standard representation of nitrogen atoms and sodium atoms. So N is nitrogen, Na is sodium. So what is meant by nucleon number? So nucleon number, you have to define it correctly. You cannot use the formula. So the definition, it is the total number of protons and neutrons in a nucleus of an atom. Okay, so determines the number of neutrons and electrons in sodium atoms. Okay, so let's see the standard representation. So you must know this one, the lower one is the proton number. Okay, meanwhile for the bigger number, okay, this one is a nucleon number. Okay, so this one you must remember that. So based on this, okay, so what is the number of neutrons? So neutron is a nucleon minus the proton, meaning that is 23 minus 11. So your answer should be 12. Okay, now number of electrons, so electron should be the same as the proton, so it's 11. Okay, so 2 marks. Right, the electron arrangement for nitrogen atom. Okay, nitrogen atom, so it has 7 electrons. So the electron arrangement should be 2.5. Okay, now if we know the electron arrangement already, so what is the valence electrons? So valence electrons refer to the outermost electron shells, so which is 5. Okay, so these are the basic concepts that you must know. Okay, now question number 3. Diagram 3.1 shows another standard representation for 3 elements of X, Y, Z. Now you don't know what is these 3. So you can see the proton number and then the nucleon number. Okay, now element Z can react with X to form a compound A. Okay, here I will suggest you to look into the protons first, then we can determine the electron arrangement. So for X, okay, so is electron arrangement is 2A, okay, 2. Okay, for Y it will be 2, 4. Then this one is 2, 6. Okay, so based on the electron arrangement, we know that this is the metal. Okay, because group 2. Okay, then this is group 14, 4, so it is non-metal. Okay, so group 16 also non-metal. Okay, so here let's see. Z react with X, so Z with X, so it's metal with non-metal. We know that it is ionic compound. Okay, so this one we must know first. Then Z can also react with Y to form the compound B. So non-metal with non-metal, so we know it is covalent compound. Okay. Now what is the formula? A chemical formula for compound A. So based on this one, okay, X and Z, we know it is ionic, right? So ionic it involve the transfer of electrons. So for X, it has 2 valence electrons, so it will release 2 electrons, right? So it forms a 2 plus. Okay, then Z, it is non-matter, so you will gain the electrons from the X, so you need to gain 2 electrons also, so it becomes 2 minus. Oh, so how to write the formula? So we can interchange the charge number, so this one, interchange it, becomes 2 2, so we can simplify, it becomes 1 1. So after you interchange the numbers, right, so you can ignore the charge, so it becomes X Z. Okay, so the answer which should be X Z. Now, what is the physical state of compound A at room temperature? Okay, so we know that ionic compound, it has higher melting point and boiling point. Okay, so at room temperature, so we know it's around 25 degrees Celsius at room temperature. So meaning that it is still in the solid form. It is not yet melt. Okay. Now draw the electron arrangement for compound B. Okay, compound B, let's see. Compound B is 2 4 and 2 6. Okay, Y. Okay, Y is 2 4, Z is 2 6. So meaning that they need to share the electrons among the covalent compounds, right? Okay, so meaning that they need to share 4 electrons for Y. This one contribute 2 electrons because it needs another 2. Okay, 2 valence electrons, right, to achieve octet electron arrangement. Okay. So based on this, actually we can use techniques like this. So meaning that this one you need 4, this one you need 2. So again you can interchange it. It becomes 2 and 4. You can simplify 1 and 2. So this one actually not the transfer of electrons. We just want to see how many atoms that we need to draw. Meaning that we need to draw 1 Y, then 2 Z. Okay. So meaning that Y. Okay, let's see. We draw the Y first. So Y needs 1 on here. We put at the center. Okay, Y is the nucleus. Okay, 2 per shell is 2 electrons. Okay, then shell number 2. Okay, it has 4. So meaning that for Z, okay, we have intercept. We need to share the electrons. Okay, Z. Okay, 2. We use the cross and dot now. So here it has 6 valence electrons at shell number 2, 2, 4. So another 2, they share the electrons. Okay, then these 2 is a dot. Okay, so if you can draw like this first, okay, so you see the Z atoms here, it is stable octet electron arrangement after it shares 2 pairs of electrons with the Y. But Y is not stable yet because it has another 2 valence electrons haven't drawn yet, right? Okay, so we draw another side now. Okay. So another one. Okay. 2, 3, 4, 5, 6. So another 2 electrons shared by the Y and Z here. Okay. So meaning that all the electron arrangement is achieved octet electron arrangement already. So you can double check. This is 2, 8. Okay, this Y also 2, 1, 2, 3, 4, 5, 6, 7, 8. So also 2, 8. So also 2, 8. So meaning that the formula will be Y, Z, 2. Okay. Okay. If you have any question, you can write in the comment box. Now, diagram 3.2 shows the formation of X bond. Okay, so we know that if the bonds is formed between the H and O, we know, okay, this is called the hydrogen bond, right? Okay, hydrogen bond. Okay, so this is name, so it's a hydrogen bond. Okay, now state the role of X bond in our daily life. Actually, for the hydrogen bond application in our daily life, you have there are few, okay, quite many actually. We can list out any one. Okay, for example, okay, flipping, okay, flipping paper, okay, is easier, okay, when the fingertips, okay, are wet with water compared to dry fingertip. Okay, yeah. So this is because of the hydrogen bonds between the fingertips and the pepper. Okay. Another one is the wet hair is sticky compared to dry hair. Okay, this is also because of the hydrogen bonds. Okay, in our daily life. Okay, question number 4. Diagram shows the chemical bonds in the molecules of compound present in the fruits. Okay, so we can see okay, all the elements. We have carbon. There are 3 types of carbons here. 3 types of atoms. So carbon, and then hydrogen and oxygen, right? Okay, there are 3 types. So state the molecular formula of the of this compound. So how do we write the molecular formula? Actually, very simple. You just go to see how many carbons, how many oxygen, and how many hydrogen. So you can count one by one. Okay, let's say you count for carbon. You will see carbon, it has 6 carbon inside the compound. So you write C6. Then hydrogen. Let's see hydrogen. How many hydrogen? 1, 2, 3. You will find it is 12 hydrogen. Then oxygen, O. You see it has 6. Okay, so this is the molecular formula of this compound. Okay, yeah, it's very straightforward, but you need to know how to get it. Now compare and contrast the molecular formula and the empirical formula of this compound. So molecular formula is the actual ratio of the atoms for each element. Meanwhile, for the empirical formula is the simplest ratio. So meaning that if we want to find out the empirical formula for this compound, right, we can simplify it. So it becomes CH2O. Okay, we can simplify it. So that's molecular empirical formula is this. Then molecular formula is this one. Okay, so now we need to compare and contrast. Okay, we can write the one similarity and one difference. Okay, so what we can write is that we can first mention the empirical formula is CH2O. Okay, we mention first. So similarity, we can write both. Okay, formula consists of carbon atom, hydrogen atom, and oxygen atom. Okay, this is the similarities. Okay, meanwhile, what is the difference? Okay, so you can mention molecular formula. Okay, shows the actual ratio of atoms of each element in the compound. Okay. Meanwhile, for the empirical formula, it shows the simplest ratio of atoms of each element in the compound. Okay, so this is the differences. Okay, so next question. Okay, diagram shows the airbag in a vehicle which is automatically inflated to protect the passenger during the accident. Okay, so what is the content inside? Okay, so we highlight this. So sodium azide, okay, is used to inflate the safety airbags in some vehicles. So it decomposes rapidly when heated to produce the nitrogen gas that expands the airbags according to the following one. So it will produce two products, sodium and nitrogen. So meaning that why it inflates here? So actually the airbag inside there consists of the nitrogen gas now. So interpret the chemical equation in the quantitative terms. Okay, quantitative, meaning that in terms of quantity. So very simple one. Okay, in quantitative terms, okay, we will focus to the number of mole. Okay, number of mole. So we highlight it. So number of mole refer to the quantitative terms. So how are we going to write it? So 2 means 2 mole of, okay, this one is sodium azide, right? Here it's mentioned already, sodium azide. Okay, so it will decompose right here. Okay, so decompose to form, okay, 2 again, right? Okay, so 2 mole of Na is sodium and 3 mole of nitrogen gas. Okay, so this is how are we going to define it or interpret it in the quantitative terms. Okay, next, calculate the volume of nitrogen gas produced from the decomposition of 19.5 grams of sodium azide. Okay, so let's see, given to you 19.5 sodium azide, then you calculate the volume of nitrogen gas. Okay, so meaning that we'll focus to this one and this one. Okay, so you have to know this first. Okay, so you are given the mass, so you can find the number of mole first. Okay, number of mole for sodium azide first. Okay, so you are given the mass over the molar mass. So molar mass we can total up. So Na is given here is 23 plus N is 14. There are 3 of it. Okay, so you total up, it will be 65. So this 65 is the molar mass. Okay, so molar mass is 65. So you get the number of mole is 0.3 mole. Okay, so once you get the number of mole, okay, so secondly we need to do the comparison. Okay, so comparison of the mole ratio. So you can see this one is 2 mole, this one is 3 mole. Okay, so mole ratio, 2 mole of sodium azide. Okay, it produce 3 mole of nitrogen gas. So from calculation here, actually only 0.3 mole of sodium azide. So what is the value? Okay, so the act. So if like this, okay, I would suggest you to use the cross multiply. Okay, cross multiply. So 3 times 2, 2 times x, so it's 2x equals to 0.3 times 3. Okay, so x you will get is 0.45 mole. Okay, so after you get the 0.45 mole, meaning that now the volume, the mole for the nitrogen gas is 0.45 mole. So we can find the volume of gas. It's a nitrogen gas. Okay, so the number of mole 0.45 times the molar volume is 24. So you will get, okay, is 10.8 cubic decimeter. Okay. Question number 5. Table shows the electron arrangement of atoms of elements P, Q, R. The letter used are not the actual symbol of the elements. So let's see P, Q, and R electron arrangement to 1, 281, 2881. So by using this, we know they are from the same group. One valence electron, so it is in group 1. So they are located in the same group as I mentioned just now. Okay, state the group for the element. So it is group 1. Okay, so give a reason. Okay, because they have 1 valence electrons. Okay, now 0.5 mole of R react with excess oxygen. Okay, write a balanced chemical equation for the reaction. So R, Cr is 2881, so it's group 1, so it's a metal. Okay, so metal will be in a solid form, react with oxygen. Okay, so during the reaction it forms a metal oxide, metal oxide, so it becomes R2O. Okay, do you know why it forms the R2O? Because R is a group 1, right? So it forms a lost 1 electron, so it forms plus 1. Okay, oxide is a group 16, so it's 2 minus, so you interchange the numbers, 2, 1, so it becomes R2O. Okay, so you need to balance the chemical equation. So 2 oxygen 2, so this one times 2, after it times 2, R becomes 4, so becomes R is 4R. So it's a balanced chemical equation. Now calculate the mass of the product's form. Okay, so you are given 0.5 mole of R, right? Okay, so you are focusing to R with what? The products. So there is only one product here, so you compare with R2O. Okay, so here we have the number of mole already, so we just need to do the mole comparison. So 4 mole of R produce 2 mole of R2O, right? Okay, so if here is 0.5 mole of R, so what do you think? This one is half, right? Meaning that this one is 0.25 mole of R2O. Okay, so meaning that your number of mole now is 0.25 mole, right? Okay, so can you find the mass? Yes. So the mass of product is R2O. So if the number of mole 0.25, you can times the molar mass R2O. So R2O is R is, we can calculate here. Okay, R is 39 times 2 plus O is 16. Okay, so meaning that you have 94. Okay, 94. Okay, so you get 23.5 gram is the mass of the products form. Okay. Now diagram 5 shows the standard representation again for Q and X. Q and X. So again, let's see the. Okay. So let's see, write out the electron arrangement. This one is 281. This one is 288. Okay. They are in the same period. Okay, 3 shells, so meaning that they are all in period 3. Okay. They are not in the same group but same period. Okay, explain why the atomic size of X is smaller than Q. Okay, meaning that this one is smaller, this one is this one is X is smaller, Q is bigger. Okay, this one is across the period from period 3 from left to right, right? Okay, so what is the points that you need to write? Okay, first we have to mention okay, both atoms, right, or both elements have same or 3 occupied electron shells. Okay, but X has more protons compared to Q. Okay, Q less protons, right? But X more protons. Okay, what is the consequences? Okay, so nuclear attraction. Okay, force for element X is stronger because it has more protons in the nucleus, right? And pull the electrons closer to the nucleus. Okay, so this will cause the atomic size for the X is smaller compared to Q. There is a reason. Question number 6. Diagram shows the precipitation of salt P by using zinc chloride. Okay, zinc chloride and lead-2 nitrate solution. So it's a preparation of the salt X, salt P. So if we know that, okay, the salt P is insoluble, you can see it forms a precipitate, right? So once you know this, okay, zinc nitrate, then another one will be lead-2 chloride. So name the reaction for the production. Okay, so we know this is the name for the reaction, so it's a precipitation. Okay, you also can write double decomposition. Is also correct. State the solubility of the salt P in water. So it's insoluble. Okay, insoluble in water. Write the chemical equation. So zinc chloride react with lead-2 nitrate. Okay, so you form the lead-2 chloride and zinc nitrate. Okay, so it is a balanced chemical equation already. Now calculate the mass of the salt P produced. Okay, so here you are given the number of mole, the volume and the concentration. Volume and concentration. So volume, concentration, both are the same. So we can calculate the number of mole first. Okay, so for both actually the same. So number of mole for zinc chloride and lead-2 nitrate, okay, are the same. Okay, so we use the MV over 1000. Okay, so you will get M is 1.0, V is 50 over 1000. So you will get 0.05 more. Okay, everybody use your own calculator and then calculate, see whether you can get this value or not. So the more is 0.05. Okay, now let's do the comparison. Mole ratio. Okay, the salt P is the lead-2 chloride, right? Okay, for this one. So both number of mole of the zinc chloride and lead-2 nitrate are the same, right? Okay, so we do the mole comparison, any one of these. So 1 mole of zinc chloride, okay, so produce 1 mole of lead-2 chloride. Okay, you can use a lead-2 nitrate also. So if 0.05 zinc chloride so you produce the same 0.05 mole of lead-2 chloride. Okay, so after you get the number of mole, okay, for the lead-2 chloride, so we can calculate the mass. Okay, so the mass of lead-2 chloride, okay, so is the mole 0.05 times the molar mass. Molar mass given to you already, so it's 278. So you will get is 13.9 gram. Unit must be stated correctly, huh? Okay, next question. Okay, describe briefly how are you going to verify the presence of cations in the zinc nitrate solution. Okay, so how are we going to confirm, okay, the chemical tests for the cations, right? So zinc. Okay, so we are going to use two chemicals, right? One is sodium hydroxide in excess, another one is ammonia solution, right? Okay, so first we mention about the sodium hydroxide first. So 8 sodium hydroxide solution into the test tubes containing the zinc nitrate. Okay, you add in until excess. Okay, so what is the observation? You will see it will form the white precipitate, right? The white precipitate form, okay, is insoluble in excess sodium hydroxide solution. Okay, by doing this, you know, okay, the presence, the cations that present, you still cannot confirm it is zinc because the lead ions, lead-2 ions, and then aluminum ions also given the same concept observation like this. So we have to use another one, that is the ammonia solution. Okay, so add ammonia solution okay, into the test tube, okay, containing the zinc nitrate solution. Okay, this one must be a new one, cannot continue from the previous one. Okay, so there is no precipitate is formed. Okay, so confirm zinc ion is present. Okay, so I put a note here. Okay, for the first one, okay, first observation here, right? Okay, you will predict it will be lead, zinc, or aluminum. Okay, so meaning that based on these three, so if we test with ammonia, only the zinc ions, which is no precipitate is formed. Okay, so you can confirm the zinc ions is present, because the lead 2 ions and aluminum ions, it will form the precipitate when you add in the ammonia solution. Okay, question number 7. A student carry out 2 sets of experiments to investigate the factor that affects the rate of reaction. The time taken to collect 40 cubic centimeter of hydrogen is recorded. So meaning that, let's see, set 1, the temperature is 30, the time taken is 90 seconds. Okay, set 2 is 30 seconds, so meaning that set 2 higher rate of reaction, or temperature the same. Okay, let's see what is the difference between the 2 set of experiment here. So here is 25 cubic centimeter of hydrochloric acid. This one is 0.5 mole per cubic decimeter. Okay, but second set is 1 mole per cubic decimeter, meaning that this one, you know that it is higher concentration. Okay, so let's see the question. Okay, what is the meaning of rate of reaction? So this one just a definition. Okay, it is the speed, okay, for reactants turns into products. Okay, or if you want to define for this question, right? Okay, you can write is the time taken, okay, to collect 40 cubic centimeter of hydrogen gas. This is based on this experiment. Okay, now state the factor that affects the rate of reaction in this experiment. So just now I mentioned already, it's a concentration factor. Okay, write the balanced chemical equation. So the zinc atom react with the hydrochloric acid, right? Okay, so it forms the zinc chloride and hydrogen gas is released. Okay, then you have to balance the chemical equation. So this one times 2. So it is balanced already. Now, right, calculate the average rate of reaction for set 1. Okay, so for set 1, we know that the volume of gas collected is 40, right, cubic centimeter. So time taken is just now 90 seconds, right? Okay, so 90 seconds. So we can calculate the average rate. Okay, average rate of reaction. Okay, in set 1, so the volume is 40 cubic centimeter divided by 90 seconds. So you'll get 0.44 cubic centimeter per second. Okay. Now, compare the rate of reaction in set 1 and set 2. So explain why there are differences, okay, between the rate of reaction in the both experiment, right? Okay, so we know that set 2 has a higher rate of reaction, right? Okay, so set 2 has a higher rate of reaction than set 1. Okay, so this is 1 point. Okay, so what is the reason? Okay, so you can mention the concentration of acid is higher in set 2. Okay, so the number of hydrogen ions per unit volume is higher Okay, so what is the next? So the frequency of collisions between hydrogen ion and zinc atom is higher. Okay, so more effective collisions produce, so set 2 has a higher rate of reaction. Okay, so here you have to mention few things. Okay, the concentration higher, so the number of hydrogen ions per unit volume is higher, and then the frequency of collision, okay, between the hydrogen ions and zinc atoms is higher, so more effective collision produced, so it has set 2 has a higher rate of reaction. Now a student repeated the experiment in set 1 by adding the copper 2 sulfate solution in order to increase the rate of reaction. Do you think he makes the correct decision? Okay, so you have to justify. Yes. Okay, because if the student want to increase the reaction, he can add in the copper 2 sulfate solution. Okay, why? Because copper 2 sulfate solution can act as a catalyst. Okay, they can increase the rate of reaction. Okay, so this is the suggested answer for you. Okay, diagram 8 shows the apparatus for the titration of 25 cubic centimeter, 0.1 mole per cubic decimeter sodium hydroxide solution. Okay, so you highlight this. This is for sodium hydroxide solution. Another one is acid, dilute hydrochloric acid. Okay, now the experiment is repeated by using sodium hydroxide with hydrochloric acid. Okay, without phenolphthalein. Okay, so salt R is formed from the reaction. Okay, so this one is a titration method. Actually, another one here is a preparation of the soluble salt of sodium, potassium, and ammonium. Now, name the type of reaction that occur in the conical flask. So acid react with alkali, so it is a neutralization reaction. Okay, now write the balanced chemical equation for the reaction. So sodium hydroxide react with hydrochloric acid, so it produce sodium chloride and water. Okay, why the experiment is repeated without phenolphthalein for the second time? Okay, without phenolphthalein, right? So to produce a salt R, actually this one is to produce the pure salt R. We want to get the pure salt R because the phenolphthalein actually is a chemical, so you will contaminate the purity of the salt form afterwards. Okay, now calculate the concentration of hydrochloric acid. Okay, here actually we can use the formula MaVa over MbVb equals to A over B. So we can simplify or assume A is for the acid, okay, B is for the base, okay, or alkali. So concentration of acid we need to find out. Okay, Ma. Okay, Va we use is 20, right? Okay. Now for the molarity or concentration for the alkali, so is 0.1. Volume used is 25. Okay. Now I would like you to focus to this A and B. A and B, where we can get from. So A is for acid, right? So you can go to find the equation here. So nothing here means 1. This is for A for acid. B is for the alkali. So meaning that this one is 1. This one also 1. It's balanced already. So meaning that is over 1 and 1. Okay, so use a cross multiply. So you will find out the MA equals to 0.1 times 25 over 20. So you will get the concentration is 0.125 mole per cubic decimeter. Okay. So just describe briefly how a crystal of the salt R is obtained from the salt solution. So you can heat the solution. Okay, produce until saturated. Okay, so after that you let it cool to room temperature. Okay, after that you filter it and dry the salt. Okay, R between two filter papers. Okay, so this is how we can get the pure salt R. Okay, now diagram shows the eggshells containing the calcium carbonate, right? Okay, so this is calcium carbonate. So when the eggshells react with the hydrochloric acid, a gas is released. So react with hydrochloric acid. Okay, so draw a label diagrams for the apparatus set up for the reaction and show how to verify the gas release. Okay, so here first thing you need to know is we need to know what is the chemical equation. Okay, so eggshell just now is mentioned is calcium carbonate, right? Okay, react with hydrochloric acid, so it will produce salt. Salt is the calcium chloride. Then you produce a type of gas is the carbon dioxide with the water. So we need to balance the chemical equation. Okay, so how are we going to conduct this? So you have to draw the apparatus setup. Okay, so meaning that you need the test tube or any suitable container to put in these two chemicals, and then you will produce the gas, right? So here also mentioned how to verify the gas. So you can deliver the test gas producer into the lime water. Then the lime water it will turn cloudy to show the carbon dioxide gas is released. So this is the diagrams produced. Okay, that's all for the discussion on the paper 2 part A structure questions. If you have any questions, you can write in the comments below. Okay, I will try my best to answer your questions. And then if you think this video is helping you, you can share this video with your friends. Okay, if you haven't subscribed to our channel, please subscribe and like this video. Okay, thank you very much.